For decades, a massive multi-billion-dollar engineering war has completely divided the global commercial aviation industry into two entirely opposing sides.
On one side is the American giant Boeing, and on the exact opposite is the highly advanced European manufacturer Airbus.
Most passengers simply cannot tell the difference, but beneath the metal skin lies a radically different philosophy of mechanical engineering.
Today, we are completely bypassing the boring trivia to visually dissect the extreme mechanical anatomy separating these two aviation giants. From traditional steel hydraulic cables to fully digitized computer networks, prepare to see how these legendary airplanes actually fly differently. The most shocking engineering difference is immediately visible the exact second you step inside the highly classified pilot cockpit area.
Boeing firmly believes that the human pilot must always remain in absolute physical control of the heavy aircraft at all times.
Their central steering yoke is physically connected to the aircraft wings using a massive network of heavy steel hydraulic cables.
If a Boeing pilot pulls the yoke hard, they literally feel the heavy aerodynamic resistance fighting back against their hands.
However, European engineers at Airbus completely eliminated the heavy central yoke, replacing it with a small, highly advanced side joystick. This joystick has absolutely no physical connection to the wings. It operates using a highly advanced digital fly-by-wire computer system.
The Airbus computer safely analyzes the pilot's input and precisely calculates the perfect aerodynamic angle required to move the aircraft.
Boeing absolutely trusts the human muscle, while Airbus entirely rely on the flawless mathematical precision of highly advanced digital computers.
Moving to the exterior, the aerodynamic shape of the aircraft nose perfectly reveals another massive philosophical difference in aerospace engineering. Boeing traditionally utilizes a sharply pointed nose cone, specifically designed to slice violently through high-altitude air with extreme aerodynamic speed.
Airbus purposefully designed a much rounder, slightly bulbous nose cone to provide a smoother, incredibly efficient aerodynamic flow over the body.
This rounded Airbus nose also creates significantly more internal space to house highly advanced, massive weather radar systems securely inside.
If you look closely at the cockpit windows, a Boeing almost always features sharp, distinct right angles on the glass.
Conversely, Airbus cockpit windows usually feature smoothly curved corners, mathematically designed to distribute atmospheric pressure evenly.
These subtle exterior differences are not just cosmetic choices. They are calculated aerodynamic decisions.
Every single inch of the exterior metal shell is completely optimized for either maximum aggressive speed or ultimate smooth efficiency. Finally, witness the massive mechanical forces unleashed when these giant flying machines deploy their heavy landing gear for final approach. Boeing landing gear relies on a rugged, incredibly brutal mechanical drop system, utilizing heavy gravity and massive pressurized hydraulic cylinders.
Airbus utilizes a slightly more digitally controlled, incredibly smooth deployment sequence to ensure absolute.
Both systems must flawlessly support over 400,000 pounds of extreme weight hitting concrete at 100 miles hourly. The Boeing versus Airbus rivalry is definitively the greatest engineering competition in the modern history of global human mechanical transportation.
Neither design is inherently wrong, they simply represent entirely different masterclasses in solving the exact same terrifying laws of atmospheric physics.
Blueprint Anatomy, dissecting the world's most powerful mechanical technology.
The global war for the skies will literally never end, and the aerospace engineering will only become more terrifyingly advanced.